Hello and welcome to Tea Leaves Programming. Today we are programming like it's 1979. We're continuing with the Haskell MOOC from haskell.mooc.fi. Today we're going to look at set 13a, which is all about monads. I really like this chapter. When people start learning Haskell, one of the problems is a lot of the materials are so excited about monads that they introduce them so early that people don't really have the motivation for why are we even looking at this. And this class goes to great lengths to delay them, to keep them until you have all the tools needed to understand them, and to motivate why we need them at all. So props to Joel Cassinan. I really like what you've done here. Exercise 2, given a list of players and their scores as a list of tuples, and two player names, return the name of the player who has more points. So what do we got? We've got our list of scores, player 1 and player 2. So we want the scores for each player, and there's this lookup function. So what we can do is bind it's lookup player 1 scores, and we can bind both scores, lookup player 2 scores. By using do notation, if any of these fails, we will basically be short-circuiting, hopping out and returning the maybe string early. So the mere fact that we've gotten here means we have a valid value, and we can say if P1 score is greater than or equal to P2 score, then we're returning the player. We're returning just the player. Else just player 2. Now we've got did I not save it? I think I did save it. Yes, we're passing exercise 2. And if you wanted to do this without do notation, you would essentially have to desugar it and use that chaining operation or something like it. Implement count and log. So given our function, some predicate, and some list, return logger. The items that pass the predicate as strings, and we have this message S, perhaps that'll help. So now if I have passed, I have just 0, 2, 4, but they're not strings. And that should give me my list of strings. And so at that point, it's just logger, stringified, did that without any monads. I mean, logger is itself a monad. So I guess the lesson here is, I don't know what the lesson is here. I think I'm doing this wrong. I think they might want me to be using monadic operations to do all this. This looks perfectly cromulent, as they say, and it does pass the tests. Using the operations balance, withdraw op, and deposit op, implement the bank op rob, which transfers all the money from one account to another account. You know, one thing I like about this set of exercises is how practical it is. It really deals with the sort of questions that I need to answer in my typical day. This is basically these three operations: balance, withdraw op, and deposit op. We want to chain them together. So I'm going to do it with do notation. We don't want to run the bank op, right? We want to construct it like it's a thunk, and then it will be run later when someone runs this. All right, it actually would have helped if I'd read the type signature here. What is withdraw op? Is that it? Get rid of our redundant brackets. I'm very, very bad at figuring out when I can eliminate brackets and when I need them. So I do actually rely on the IDE to tell me that. All right, so this one was interesting. I started down the road of trying to get all in my head about, oh, when do I have to like construct an op? But really this is just chaining these operations together. It's that simple. Calling balance from, if you were writing this explicitly, you might have started doing the thing that I was doing earlier. This is a case where writing it in do notation is probably harder than just chaining it. But the result of that balance from is being fed into withdraw op from, which is a partially applied version of this. So we've partially applied it by giving it the string, and then the int is being fed into that, and then that's chained to deposit op. Let's see if this is actually correct. And it looks like it is. No, because I didn't save the file. All right, it does in fact pass. So that's great. So all of this, I think, he's doing it again. Joel Kassanen, you're brilliant. What he's doing here is building up all of the intuition for the state monad without mentioning the word state monad. And then in exercise 7, now he's actually introducing the general version of this pattern. So we've gone, once again, he does this all the time in this MOOC, and it's great. He starts with the specific, the concrete, the actual real implementation, and only then generalizes it. My big complaint with a lot of Haskell materials is that they start maximally general and then give examples. I think going the other way really makes the intuition a lot more accessible. Update the state based on a single character. Open paren should increase the state, and a closing paren should decrease the state. And it looks like we don't carry any parameters through here. It's just the state that we care about. So a first implementation of this, which is not going to be quite correct, +1. And then this parent. Do it as +(-1) like that. Yep. So this is not the whole story, because this will not catch the case where if it goes to -1, it needs to stay to -1. But let's run it anyway and see if that core functionality of increasing and decreasing is working. Is that an unnecessary pure? No, I actually do need that. So if val is -1, then do nothing. Otherwise, modify the state. I've got this in the wrong place, don't I? In fact, I need this in both situations. And this needs to be +1. A little ugly. We could actually case on this instead of making them separate functions, but I think that should still work. Does it matter that I have unimplemented, what happens if we pass something other? It might. We might need a catch-all case here that does nothing explicitly. Let's add it just to be. Yikes. Right, that's exercise 8. Well, we've lived up to the name of this series, Haskell for Dilettantes, because today I definitely feel like a dilettante. This was set 13A. We'll be doing set 13B soon. Thank you for joining me on this journey where I embarrass myself in public. It's been a lot of fun. You're watching Tea Leaves Programming. We're programming like it's 1979. Thanks for watching.